nanoHUB.org.
Online simulation and more for nanotechnology.
Good afternoon, everyone. I'm Dr. Kelsey Rodgers, and so I'll be the one that's presenting today. And today we'll be going through MATLAB. So to get started, I'm going to show you how to access MATLAB on nanoHUB. So if you don't have access to MATLAB, which is not a free open source software tool, it is a software tool you have to pay for. Some universities have it. But either way, if you don't have access, you do have access through nanoHUB. So one easy way to get there if you don't have the link is to go ahead and search for it. So on nanoHUB, there's two main places where you're going to find the search. If you see a little menu in the top right corner, then you can click menu and you'll see the search bar here. If I'm in a full-size screen, then I will see the search bar. It'll just say search. So then when I'm searching, I can just search MATLAB. And it is not the first option, but the third option here that may change at some point. So just pay attention and look for MATLAB use, which you could even go search MATLAB use. So once I go to here, I can full access to MATLAB tool on nanoHUB, and I can launch this tool. So you see, and this is the same way it'll look if you're launching it on your desktop. It does that same kind of launching with the MATLAB little logo and the loading screen, and then you get into here. If you have not used MATLAB before, then your main screen will probably look something like this. So today we'll be getting into script files more, which is what's popping up right now, and talking about how to use MATLAB as a calculator, how to use it, collect inputs, display outputs, and different things like that. So to get started, I want to give a little bit of background for everyone who's in here. So I used MATLAB to look at all of your responses. And this just gives you an idea of some of the things that you will be capable of with MATLAB if you want to be. We are not going to get this far today because this is a lot of content to cover, but I do have a full tutorial online that you can go through at your own pace on YouTube. So there's videos there, and I have a bunch of different code provided to help you through every different step of how to learn to do something like this. So for starters, anytime you see this message, when you start getting into this point, always say change folder. I will talk about that more later, but just because I know I've seen a lot of people who see that error, like that little display error message, and not sure what it means. This is an example of plotting. So here I've done some plotting. I've analyzed some data in MATLAB. So I started with the Excel file that had all the data of everyone's responses, and then I was able to analyze that data to give these different plots. Again, I just want to give you like a little bit of introduction awareness, and then we can go in and start doing some different things in MATLAB, starting more introductory. So there's a lot of things you can do with MATLAB. Many of you said you did use MATLAB as a calculator for those who did have experience, and you've done some plotting, and then again, maybe a user input. So this is a code that is posted on MathWorks, and you can find it through my YouTube channel page. I have all my MathWorks links on there. So this is an example of what's kind of like a very introductory level type simulation almost. So right here, this is my command window. So just to get familiar with the MATLAB environment, everything, when you're interacting with your user, you will be in this command window. So this is a place where I'm collecting an input. And so I ran my code and I'm collecting an input from the user. So pretending that you took this code and you were just like, okay, I want to try running her code that she has, that this is developed. You would, as a user, put in the response to this. Now this particular code, I don't provide a lot of context. Sometimes when we're interacting with users, we need to think about how much context do I need to give and what's going to be the application of whatever program I'm developing. If I'm doing something just for myself, I don't need any context at all, really, just enough to like familiarize myself with what is it that I was really doing when I developed that code. So in this case, I used a formula to make an approximation of pi. So we're all familiar with pi, 3.14159.225, da 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 da, so on. So this particular program uses an existing formula to calculate an approximation of pi. So for instance, if I were to say plus or minus 1 for the approximation of pi, that would be awful. But this would be an example of what this code looks like. So there's not a lot of information here. It just says 4. It looks kind of weird. This was really developed more so for the purpose of creating an approximation that's a little more closer to the actual value of pi. So see here I have a few plots displaying, and again, this is something that MATLAB is capable of doing. I can do a bunch of different equations, I can display the results of those equations, and that's what I've done here. So in this, again, there's a lot of code here, so please don't be too overwhelmed. What I want you to know is I have an underlying formula here. So this is a formula that I've put into MATLAB. I could stop with this, and this would just be an example of using MATLAB as a calculator. This particular formula is a summation, so I actually have it adding up upon itself, like a summation would. So that's another thing that you can do in MATLAB. Again, you can plot any kind of line in MATLAB. This is an example of me putting my name here in MATLAB, just plotting a bunch of different lines. There's a lot you can do with plotting. It's a very powerful tool for plotting. And I don't have any examples of 3D plots, but yes, you can do 3D plotting as well. Another thing that you can do in MATLAB, again, we already went through analyzing data. These are different types of plotting, equations. You can go even more complicated and go to the level of like, I want to create a graphical user interface. This particular one is tic-tac-toe, so I'm sure all of you have played tic-tac-toe at some point. You can decide I want to be player versus player or player versus computer. So I'll do player versus computer. And go ahead and start that game. And this, it says I go first. So I go, and then the computer goes. And then in this case, I won. And I gotta move that. And then I can say, okay, play again. And so again, this is just, I'm gonna see if I can get the computer to win. There we go. So this is just one example of a graphical user interface. Sorry, I just closed it, so it causes an error. But this is, again, just, there are a lot of different things that you can do with MATLAB. It's a little more user-friendly if you don't have any experience with coding. It's, in my opinion, one of the easier languages to get into because it has the same kind of concept with the for loops, if statements, switch case, all the same basic programming language logic, but it's a lot easier to work with as far as data. So, for instance, we are all familiar with how an Excel file looks, hopefully. Let me change folder real quick. So again, this was the results of everyone's responses for registering. And if I look at this Excel file, I've already removed everyone's name, so don't worry, that won't pop up. So here I'm seeing an Excel file, very familiar, hopefully, this table format. Now, when I read Excel files into MATLAB, that might look a little complex, but what's happening is all my data is coming into MATLAB in the same format as my Excel file. So MATLAB interfaces with Excel really well. So I'm going to go ahead and open this variable so you can see it. So basically, this looks the same as my Excel file here. So I have this Excel file. And again, the same thing here in MATLAB. So it's a lot easier to handle data, to analyze data, to sort data, everything. MATLAB's a really good tool for that. So if you're on a research project and you're doing anything with surveys or collecting data from any instruments, and you have the data in a CSV file or an Excel file, it's very easy to import that data into here and then be able to get to the point of breaking that data apart and understanding what's happening and using it to create, again, plots or to do statistical analysis and any type of analysis that you are interested in. And then again, if you want to display the results in a research paper or any type of paper. So just getting familiar with this whole environment. If anyone has any questions at any time, I would love questions so then I can help navigate different directions of what you're most interested in. But otherwise, I will just go into fresh getting it started in MATLAB and where to start with a brand new script file and what are the environments. I'm going to go to this version here because, again, this is what it will probably look like more so when you first open MATLAB. So the first thing I'm going to do here is I'm just going to close out of these script files. So a lot of times when you open MATLAB, it'll look something like this. The main thing you need to know here is your command window. You can do some basic coding in your command window, but it's not a good idea because it's not going to store all your data, and again, you can't replicate what you do. But if I wanted to do something simple like establish a few variables, or say I can write something simple like this. MATLAB as a calculator. So if you have familiarity using MATLAB as a calculator, you may have done everything in this command window. And again, this will work just like a calculator. One of the big differences between MATLAB as a calculator and MATLAB, so like when I use a calculator, I can put parentheses and say something like 5 times, well, let's do 5 plus 6, and then times 3. So if I write something like this in a calculator, the calculator will know that those parentheses are multiplication. In MATLAB, it does not. So this one, it was nice. It actually corrected me and knew what I was doing wrong. And it tells me I need to put a asterisk in. So I need to say multiplication. Sometimes it won't catch that and it'll just say invalid expression. But here it does, again, give me the suggestion of what is correct. So this is one of the big differences with just simple mathematics using MATLAB as a calculator. Just be careful of, there's going to be some differences. So the cool thing beyond just like having numbers in here, I can also have words. So I can create strings. And these are going to be the most common data types that you're probably going to be dealing with, is mostly numbers and strings. Another data type that you will also be dealing with is probably going to be some logical data for most things that you're going to do. So logical is just meaning true or false, 1 or 0. This is Boolean, is how some people might be familiar with it, but really true or false, 1 or 0. So here I just tested, is X greater than Y, and it says no. But if I were to say the opposite, is Y greater than X, it's going to say yes. So if you're not recalling what X and Y are equal to, a good place to also know is your workspace. So this is another very important window in MATLAB. And this is where I can see all of my current variables and what they're equal to. So I see X is 5, Y is 20. So then I know, okay, I have 20 greater than 5. That makes sense, checks out, true. And then that's going to be, so this is a, I'm not going to get too deep into this language, but this is a relational operator. This is the very beginning of getting into the idea of if statements. So if statements are on a very like simple level, just anything. If I say, if it's raining outside, I don't want to go for a bike ride. I'm putting a condition on what happens next. And then I can say, if it's sunny outside, I want to go kayaking, or something like that. I have now said a condition, and based on that condition, the next part's going to happen or it's not going to happen. So those are examples of if statements. And again, the fundamentals of what you need is these logical data types, which is either the true or the false, because I need to evaluate, is this condition true or is this condition false? And then that determines what happens next. When I get into writing script files and actually creating code, that will be in a script file. And so you can do this a bunch of different ways. I can hit this button that says new script, which will create a new script file. Or I can hit the button new live script. This is a different way of interacting with MATLAB. They're both script files. They both run the same way. The difference is, let's see if I can get it to where, okay. The difference is it'll start showing on the right-hand side, and it gives you a little bit more feedback. So I've known some people who prefer to work in a live script, and some people prefer to work in just a regular script file. So that's something that I would say, find your own preference. I personally always use the script files. To be honest, a big part of that is live script files came about a while after I was really familiar with the MATLAB environment. So I have had former students that preferred to always start in the live script files, and I've had some students that prefer to just stick with the script files. So again, there's a lot of different ways to use this tool, and a lot of it is going to require your own effort of just trial and error, figure things out, see what you like, see what you don't like, and just try different things. So again, I recommend trying the live script files and the regular script files and just see what your own preference is. Because again, so we see here I have everything kind of displayed right there on this split screen. If I write this same code, which I'm just going to use copy and paste, because copy and paste is going to be one of your biggest friends anytime you're, oh, I guess I'm not going to use copy and paste. So here I like not being in the script file, the live script file, I actually have to save this. And see, it does not show up on this right-hand side. And instead of being single points, I created a vector here. So, and now it's going to pull up the plot here. So this is an example of, again, just creating a first script file. And this I would classify as still doing just MATLAB as a calculator and then getting into some type of output like a plotting. So this would be very basic, but again, this is where it starts. So I would recommend starting with, I do have a bunch of sample programs of like where to start, how to get familiar with what is X considered, what can X be, X is a variable, and you can have pretty much any type of variable name here. And if you saw what just happened, I just swapped out all the X's for variable names. So it gave me this little pop-up. It's like Shift Enter to change everything. I can do that. There's a lot of cool features in MATLAB and shortcuts that I don't think I could even get into every single one of those shortcuts in this period of time if I could, because again, a lot of them wouldn't be relevant until you start getting further into MATLAB. But as you go through MATLAB, you will start to find tons of shortcuts and features and things that can be very helpful. One of the other things that's very user-friendly about MATLAB is, like we saw before with that error when I tried to do the parentheses and I didn't put a multiplication sign and it corrected it for me. It told me, like, you said this, but I think you meant this. It does that a lot of times. So here, yes, I'm going to go back up. So again, this was that example with the parentheses. It automatically corrected it for me and it said, well, you really want multiplication, so put a multiplication sign. And then some of you might have caught this error showing up. I just kind of glossed over it really quickly. But this one, it's looking at, basically it's trying to do matrix math. And it's telling me if you're not trying to do matrix math, like you need to put a period in front of that power sign, so then I know like raise only every individual point as one thing. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, which is what I meant. So I had to put a period there. So again, if I do this, same error will come up again. So again, MATLAB is very good with its errors. So if I look on this, it tells me exactly where it is. Error on line 2. And then it tells me what's happening. So I would say don't be afraid to just explore and try MATLAB in a lot of different ways, because again, it's pretty user friendly. It's really good at giving you that feedback and helping you see like what errors are happening. One thing that I would say is also very important when you're new and even when you're not new is running your code frequently. So hopefully some of you are following along and maybe even have like a split screen going on where you have this on half your screen, or maybe you have 2 screens, and then you have MATLAB on another screen, and you've kind of tried some of this out too. And if you have and you get stuck anywhere, please ask me any questions you have. So I would say try it and run frequently. So again, if I am brand new to coding, I don't ever really want to write more than like a couple lines of code before hitting that green run button, because I don't want to have to troubleshoot 30 different lines of code all at once. I see people who are new to some type of software like this, new to coding, get a little overexcited about putting together a code, and they'll put together something that is, let's say, like this one. This is not that long, but it's still 63 lines of code. And they'll write all of it in one sitting and then hit run. And it's not a good idea. You don't want to run your code after you've already written everything. You want to run your code all the time. So it's like when you're writing an essay. And sometimes when you're writing an essay, you might not hit spell check until the very end of your essay, and then all of a sudden maybe it catches like 20, 30 different things. With spell check, that's not too overwhelming in my opinion. Maybe it is to you, but I can tell you with programming, it gets very overwhelming. So for instance, I'm just going to give you an example of like breaking this. So if I just go through here and mess up my code. Let's see, let's add a few more errors. And I just start to run my code, I'm going to have this problem where it's going to walk through a bunch of different errors, and it might get discouraging. So the first error it tells me is like, it says, this variable that you're calling here doesn't exist. And again, it helps me. It says line 16. So if I look here, I can say, okay, I have this variable tolerance. Cool thing is, again, it actually highlights all the variables for me that are the same. And I know that this and this are also supposed to be the same variable. So in this case, I can copy, paste, paste. I actually caught that one at the same time, and then run it again. So again, it starts going through and it just keeps giving me different errors every time I run. And it can get really discouraging if you're trying to go through and catch all of these errors and you keep thinking like, okay, now it's gonna work. And then it's just like, error. It's thinking, waiting to get to the other error. Oh, okay, I know what the error is now. So in this case, my code's just infinitely running. So once you start getting into while loops or any type of looping, it's going to be important that you know Control-C is not only for copy. Control-C will stop your code from running. And so you can see here, I have this plot that you can't really tell what's going on, and it's just because I have a ton of different points. My I jump over here in my workspace, my while loop just ran 8,412 times. So there was clearly a problem with something. And if you remember what I did, I took out a 4 here. So if I look at my value for pi approx, it's not anywhere close to the value of pi. So I created a mathematical error. Which this will now fix. And again, I have another error. So my main point, after you write 2, 3, 4 lines of code, just run it. And sometimes it might seem silly. You might be starting a code and you think, okay, I know my x variable is equal to 5, y is equal to, say my slope is equal to 3, y equals m, x plus b, and I'm putting in errors on purpose. And then I'm like, okay, I want to keep going. I want to plot all this, and it's just stop and say, okay, let me just test my code, see where I'm at right now. And then, oops, I gave it an invalid name. So if you notice what just happened, I got rid of the .m, and MATLAB did not like that, so that was invalid. Now I can actually run the code. So if you come across that, you have to have a .m as your extension. So just like you would have .docx, .xlsx, .xls, you want to have a .m file. So when I run this, it says unrecognized function or variable mx, and it says it's on line 3. And I look here and I say, no, I want y equals mx plus b. What did I do wrong? I want y equals m times x plus b. Exactly. And yep, exactly. So then you already caught the next error. So the next error is going to be b is not defined. I haven't given b a value. So again, it's important to just start slow. If you are newer to MATLAB, just start like one step at a time. Because if you're trying to jump in and just run everything, and I want to start with a program like this, or I want to start with even worse, I want to start with something like a graphical user interface, it's going to be a little discouraging. So I would start with smaller problems. And again, I have some of those smaller problems on YouTube, and I walk through different smaller problems that you can walk through and code with me as I go through them. This is just one example of one. So another type of step that you might be interested in is, let's say I want my y-intercept to change. So I can say, okay, instead of having a set y-intercept, I actually want the user to tell me what the y-intercept is. And however you want to format this text, you can play around with that. But I've just used a function that is inside of MATLAB. So MATLAB has tons of built-in functions, and one of them I've already used a few times is plot. This one is input, and what this does is it takes this text and displays it here in my command window. So my user can then say whatever they want to for the y-intercept, which will then keep changing these values. So I want to also make you all aware of 2 very critical functions that I recommend starting every script file with, and that is CLC and clear. So right now we see a ton of different things in my command window and in my workspace. So let's first take care of my workspace. If I want to clean this up and say, okay, clear all of this out, I can say clear. And now everything in my workspace is gone. One of the reasons this is so critical is, this is an example of a comment, by the way. I just got rid of line B, line 5 basically. If I have B equals 10 in my workspace and I don't clear anything and I run this code, my code works. So I might think that my code is working and everything is fine. But the second that I start my code with clear, now all of a sudden it doesn't work because B doesn't exist. So anything that's in the workspace will be read in my script file. So it's important that I say clear, I want to start with a fresh code, like I want to start with everything fresh. I don't want any existing variables to be sitting here in the working memory kind of the script file I'm writing. So now it matters that I say B. And on the other hand, this is looking kind of messy. So my command window has everything that we've done so far all over the place. And sometimes when you're running a code, you don't want to have to see everything that happened beforehand. So what I can do for that is the function called CLC. So that one's not as obvious to remember, but this one clears the command window. So now you see everything in the command window is cleared out. And I'm just putting these so you have examples of something in the command window. So now I'm going to add that in the beginning of my code. So again, I say always be sure to start your script files with CLC and clear. Clear being the more critical because again, this clears the workspace. And then this one's still good for just cleaning your command window. And that one's, again, a little bit more of a preference and to make it look nicer and just make it easier to figure out what's going on. CLC. There, okay. So then right now, everything in my command window is related to this simple calculation. So this is just MATLAB as a calculator with the user input involved. So I have some type of equation, some type of inputs. And again, these can get as complex as you want them to be. A lot of times, we'll go into another example of like, if I want to just take this one step further. So here I'm working with all scalar data, all 1x1s, and I just want to go ahead and change this to a vector. So I'm making this numbers 1 through 5, or let's say even -5 through 5. And I go ahead and run this same code. So now we see x is no longer a scalar, it's a vector. And I keep picking 10, so let's do something different. And then I have my values for y here. And again, just very basic initial plotting. I think this is a good place to start for plotting, is just with very simple equations, and then eventually getting into the complexities of plotting data or plotting different formulas and the process with those formulas. So then now you just see my line here. And again, I have a whole series of videos that gets into details of plotting. So if what you're doing in your projects has to do with plotting and you want to do titles and labels and all of those things, all of that you can do. Because again, let's go back to our first initial plot that we were looking at the beginning of the workshop. So here we see I have a pie chart, I have a bar chart, and those we were just looking at line charts. So there's a lot of different types of graphs you can use. And then here again, you see I have titles on there, I have labels for everything, and I have different types of complexities that I've added in that are important for this display. So there are a lot of different options, a lot of things you can do. And again, this was an example of all of you answering to the registrations and registering for this event. And that's something that maybe a lot of you have interacted with at some point on a research project. If you're getting information from participants or collecting data in any place, having that Excel file and having something that can help you analyze all that data in the Excel file beyond just Excel can be extremely helpful. Especially if you've ever gotten to Excel and you've tried to do something like an if statement inside of Excel, which you can do. It's actually a lot more user-friendly to do that in MATLAB once you get past that initial hurdle. So I've said a lot. Does anyone have any questions about what MATLAB can do, can't do, different things that you're working on, projects, why you're interested in MATLAB, the more simple version of just getting into MATLAB, getting familiar with the environment, anything related to any of those parts.
Yes, we do have one question, and it is, can MATLAB be used in Python?
I have not had experience doing that. I think I remember reading a blog where somebody was having a debate about that. And it was basically like, why would you do that? I guess that would be my first question is, why are you interested in doing that? If you're familiar with Python and you know Python well, and part of it is like the transition, I think the transition, I will just say, I think the transition from MATLAB to Python is a lot harder than the transition from Python to MATLAB. So from all the students that I've seen transition, again, from one to the other, I've seen they have a lot more struggle transitioning from MATLAB to Python because, again, MATLAB is very programmer friendly. The types of error messages that you're seeing are a lot more specific, a lot more helpful. The way that it holds the data, integrates the data, analyzes the data, it's a lot more user friendly to work with these different types of arrays of data than what I've seen in Python. If part of the reason for running, because Python is open source, nanoHUB now has MATLAB open source to you. So basically, so if you want access to MATLAB, and part of it is like, I don't have access to MATLAB, yes, you do, right here through nanoHUB, free for anyone. Did they respond by any chance of like why they'd be interested?
I believe this is the response. I didn't know that MATLAB was its own IDE. Does it use its own programming language?
Yes and no. Yes. Yeah. So it has the same like for loops, if statements, logic, while loops, all of that, but it has a bunch of its own built-in functions. But I think that, like, if I recall correctly, I think the roots of it, this would be more of like getting into MATLAB side of it. I think the roots of it started with something around, I think it started with C. I would say Google that. And then again, like, I'm not an expert on like the development of MATLAB. So that would be on that side, the development of MATLAB, but it is its own software application that you can use and you can program in. And as far as like, it can interact with other applications. So I can interact, like it can interact with reading content from an Excel file, pulling content from a folder. You can tell it like access a folder, and then you can say which file you want from that folder. But if you're going to go like hack some computer, you're not going to use MATLAB. If you're trying to do hacking, don't start in MATLAB. Hopefully that's not your goal, but I mean, maybe like as far as a career path for security and all that. But if you want to track, like there's in MATLAB, I can track mouse movement, I can track any key interaction, I can track anything and everything someone does on a computer with MATLAB, which is getting into the graphical user interface side, like that example I showed with tic-tac-toe. I didn't get into that detail of like pulling keys, like what key someone pressed and like where their mouse clicked, but you can do that. Okay, so I guess I will just say for any of you that if you are looking for someone to like a place where you can have help walking through one program at a time and like walking from the very beginning into like every detail, knowing the language, understanding what's going on. I do have a full tutorial. So again, it's going to be a lot longer than an hour to get through this full tutorial, but you can change the speed, you can pause, you can play, depending on whatever pace you want to go through this. So it's like getting familiar, getting into the script files like we've just gone over, getting familiar with variables as we've done, and then again, like starting to write code, which we kind of got into these three, and data types, we talked about that some today. inputs and outputs. We got in a little bit to the inputs. And then again, like the built-in functions, that's the example of like the CLC, the clear, the plot, the input, those are all built-in functions in MATLAB. So in MATLAB, there are functions that are already created by the developers, and those functions you can use and call, and there's a bunch of code behind them. So the developers of MATLAB wrote code and established it as a function so we could use it in any of our writing code. So when I want to plot something, I just call the plot function. And that's what a built-in function is. And there are a ton of them in MATLAB. And then again, getting into the if statement. So that's like that logic we were talking about, but actually writing an if statement in code. And then going into like while loops, I would say would be the next step. So I would say the next step from here would be, again, maybe getting more into the inputs, outputs, built-in functions, and then getting into coding if statements, while loops, if you're wanting and interested in that logic, which I can tell you for most things you're going to do, you're going to need some type of logic. So when I'm analyzing this data, I'm using for loops, I'm using if statements, I'm not using any while loops here. Versus like the pi approximation, it's pretty much all while loops. So this while loop isn't a necessity. That's more for dealing with the user input, but I think it's important and helpful. This one is part of my calculations. So in order to have that iterative process where I keep continuing my summation, I needed a while loop. And depending on this context, like that's also why I needed a while loop. Again, getting into the plotting. When I wanted to do something just as simple as plotting my name, this is just a bunch of different lines. There's no logic involved in this process. I don't need logic to do straightforward calculations and plot them out. So here, you're not going to see any if statements, any while loops, anything like that. It's just there's doing calculations, so I could plot a circle, and just creating lines, again, creating a bunch of lines, sine waves, rotation, it's all math. That's all that it is that's going on in here. I don't have any logic. If you want to, again, do any type of data analysis or complicated equations, you are going to need to get into the logic side, so the programming logic, which is like the if statements, the for loops, the while loops, all of this part. And then this is a different way of approaching it. It's getting into games and stuff. Arrays, we talked about vectors a little bit today. So remember right here, we have examples of vectors. And I will just say, if you didn't know, MATLAB stands for Matrix Laboratory or Matrix Laboratory. So if you want to know what software is going to handle matrices the best, probably MATLAB. It's really created around the idea of handling matrices. So any type of data that is 2D or 3D or more complex, that's when you're really going to want to use MATLAB. It works really well for any type of matrix math and any type of matrix data. So again, like that Excel file we were looking at in the very beginning with all the registrants, and then seeing that Excel file, how it looked in MATLAB, it's just a different type of array. It's an array of data that has more than just numbers. It has strings and it has different complexities to it. So MATLAB is going to be really good with any data handling in arrays. And I would say it's going to be important to dive into arrays more and understanding, okay, what are arrays? What does it mean to have a row vector versus a vertical vector or a column vector? What does it mean to have a matrix versus a vector? What are those? How are they different? And then once I have them, how do I manipulate them? How can I make them smaller? How can I make them bigger? How can I take out one piece of them? All of those types of information, that's called slicing, augmenting, diminution. And again, getting into the idea of interacting with Excel. And just like there are functions in MATLAB, so you will see this code is an example where I do have some functions in here. This is, again, a graphical user interface, whole different level of complexity. But in MATLAB, just like you can call a function, you can actually create functions that you can call in other script files. So here's a good one, I think. Oh no. But I have some other ones where simple. Anyway, so calling a function, just as simple as we can call the plot function, you can create functions that are then built into your folder. So then I can have a function that, let's say, I know that every time I run an Excel file, I want to go through and find missing data points. This is an example of me looking for a missing data point. I could put something like this, put my code in my own function that I create, and that way I only have to write the code once, and I can just call it multiple times. So that's very helpful to know, but again, it's a whole nother complexity of it. So it really depends, like, what are your goals? What do you want to accomplish? And how much do you want to dive into understanding and using MATLAB? As I've said before, there's getting into the strings. So when I say strings, it's just anytime you see this purple text, that's an example of a string. So here's another one, that's a string. These are all strings. So anytime I have text in my program, I'm working with a string. There's a ton of different functions you can use with strings. This is an example of one of them because I was looking for, okay, how many people said, again, they had no MATLAB experience, so anyone who wrote none would show up here in this 74%. And then anyone who had anything that didn't have none, then they showed up in this other almost 26%. And then again, I had to look for these specific text points to know, okay, who all has plotting experience? Okay, I have everyone who filled out the registration. 8 people had plotting experience. So there's a bunch of details getting into strings with that. And then again, plotting is probably one of the other most useful tools. I would say the main things that I use MATLAB for personally has a lot to do with data analysis, changing Excel files. I've had a lot of things where I download an Excel file, and once I have this Excel file with all this data, it is a mess. And there's tons of rows to go through and figure out, okay, what's incomplete data, and I have to delete that row. And if you only have 20 rows of data and you have 2 or 3 incomplete rows of data, not a big deal. You can just manually delete them. But think about if you have a data set that has 30,000 rows, you are not going to want to go through and manually delete every row that doesn't have a piece of data in it. So that's when it becomes very helpful to know how to use MATLAB and say, okay, I can just read this into MATLAB, look for any rows that are incomplete, and then just delete them out. And then I can even re-export that out as an Excel file. And I don't even have to do my analysis in MATLAB. Or since it's already imported in, I'm going to go ahead and analyze some of the data in MATLAB. So I would say that's probably where I feel like it is most useful in like my everyday application of things. So every time I have survey data, I've worked with clients that have Excel files that they've downloaded for, let's say, a lot of them are like health records, and their interface and the way that they download that data, it doesn't work for something else that they need. So I'll do like reformatting, writing a program that then can take any one of their Excel files in the same format, reformat it, and send it back to them. And that way they have all the data they need reformatted. It's great for that. And again, getting into the analysis side, it's amazing for that. I actually just recently posted a video about using MATLAB to analyze open-ended responses. So when somebody writes in like the survey that y'all filled out coming into this to register, you had a question that said, what was your experience with, or like, what are you interested in getting out of this? What do you want to get out of this workshop? And then you had to write in text. So that's an open-ended response. And so I went into how we used this MATLAB tool to analyze over 4,000 students' responses to what they thought a model was in engineering and what are types of models and describe those types of models. And it looked at over 4,000 responses and then was able to determine what types of models were in their responses based on a bunch of keywords, a bunch of time, a huge framework, and all these different things. But it was nice to be able to have the ability to put together a tool, a program that could then actually analyze all our data so we didn't have to manually go through and read all 4,000 plus responses. And then again, it's easy with the quantitative stuff as well, any type of statistics. I will say if you're doing statistics, there are other softwares out there like SPSS, SAS, R, a lot of other ones. And then yes, there are other programming languages that you can, like full-on language softwares that you can use. But I would say, like if you're doing all linear regression, yes, you could do that in MATLAB, but it might make more sense to use something like SAS, which is a statistical analysis software that's specifically for linear, like it specializes in linear regression. So everything has their different specialties. SPSS is another statistical software that a lot of universities might have access to. And that's really good for any time I'm doing like an ANOVA, ANCOVA, t-test, or any of those types of statistics, MANCOVA, any of those. And then R is really good getting into, it's going to be a little bit more like how MATLAB is. It's going to require more programming on your side to actually analyze your data, but some people prefer R as well. So again, you can do that in MATLAB, but MATLAB probably wouldn't be the first software I would choose for doing like a t-test or some of that analysis. But again, you can. It just might require a little more effort on your part. In fact, I'd probably do a t-test in Excel before I would do it in MATLAB personally. But if I want to plot my data, or I want to look for patterns in my data, or I'm working with text data, I would definitely lean towards MATLAB. And again, if I want to in any way clean data that I have, MATLAB is a go-to for that as well. Or any type of equations, modeling, MATLAB is where I'm going to go for that, because again, the way that it interacts with arrays and the way that it stores those arrays and organizes those arrays is much more user-friendly than any other software that I've heard of or seen. All right, so I realize it is like the end of our workshop, and I really appreciate everyone hanging out, and hopefully you got out of this what you were hoping to, or maybe even more. Thank you. Thank you so much again for hosting this.
This was really great. And, hearing about how MATLAB works with arrays and for data cleaning, our team has some messy data that maybe we should all try out MATLAB for data cleaning and maybe work with you some more if we run into any problems.
Yeah, absolutely. I do a lot of data cleaning. Yeah, it works really well for that. It's nice. It's nice having access to something where you can just like download all your data, not have to touch it, and then just run it through a program, and then you have like clean data to actually look at. Or if you want to like even have like add, like it automatically analyzes it. Like the one that I did recently. So this is the one that I was talking about that I did a video on recently. So here we analyzed over 4,000 students' responses on first-year engineering students' ideas of models coming into engineering and then after their first semester of engineering. And so, as expected, like a lot of students came into engineering thinking about physical models, but then after some interventions related to mathematical and computational models, a lot of them started transitioning, thinking more about those, but still remembering, obviously, these other types. But this was like data collected at 3 universities over 2 years.
This is great. And when you just now ran this, these tables were regenerated just now?
Yeah. Yes. So they're regenerated every time. So then it tells you how many data points it looked at, and then how many were complete responses, and then how long it took. I add that in just for fun, but so reanalyzes the data every time. So if I were to go to like this one, here, I'll show you with this one. This one has two sets of data in here. So if I run this one, it's doing the same analysis, but it's analyzing, this was 636 responses that I just kind of like deleted a bunch out. So it was a smaller data set. So then it analyzes it right here pre-post.
This is really nice. Very
Yeah.
impressive. Very inspirational.
Okay. And then, yeah, so then that, again, if I just put in a different Excel file, it does the exact same thing. It runs. So now it tells me it's 301 students, and then it's showing me the data looks different. So like this one, for some reason, a ton of students thought about physical models and not as many in the post, but then again, like way more with the mathematical models, computational models after their first semester of engineering.
Very nice.
Nice. Yeah, so I mean, I think it's a great tool for student researchers to get into analyzing data. Again, even if it's just cleaning data, it makes a world of a difference. Because like this one, that one, there was no missing data removed. But like the other one, I think there was 300 out of the 4,000 some.
And when you say just cleaning data, I read somewhere that cleaning data might take 80% of your time, something like that.
And this did it, clean the data and analyze the data in 0.72 seconds.
Wow.
For 647 data points.
That's a definite advantage. I think this is very compelling, a very compelling example of how MATLAB can be a real help.
Yes, absolutely. But again, like this, I would say is great for this point of like the plotting and getting all the graphs in place. But then when it came to like the final t-test of analyzing like, okay, is there statistical significance between this pre and this post? You could do that in MATLAB, but that I would honestly prefer other tools for that. Like I would probably download out, like export out the cleaned version of the data and then just throw it in SPSS if it were me. Just because SPSS I like, and it's more like reliable in my book of like using the t-test. Like I know I'm not gonna, like I have all my options right there to make sure I don't do anything silly, like make an assumption about my data type that I shouldn't have made, or you know, and I have like the U test or whatever, the Mann-Whitney version too, for if I have non-parametric data. So anyway, cool.
Very nice. Well, thank
Thanks for your
you.
time. Thank you.